between this configuration and patch P would be to change some of the keywords. Right? I've decided that I'm going to go ahead and set up my ether channel with ports number 1-1 and 1-2 on one switch and 0-2 and 0-3 on another switch. So what do I do? Interface range, we know what that command does. That allows us to configure more than one interface at a time. I set up my channel group number, okay? The channel group number, I can choose whatever number I want. There's no difference between one number or the other. In this case, I've chosen channel group number 1. And by saying mode active, I'm specifying that I want to use LAC-P. It's that simple. Notice that as soon as I type channel group 1, mode active, a port channel interface gets configured. Now the port channel interface is a logical interface that ties to the physical port. Also notice that all of my logical configurations, setting up the port as a trunk, setting the encapsulation on the port, setting the truncated VLAN, all of that gets copied or done under the port channel interface, not the physical interface. Right? Remember, interface, well, you don't really need the range there. I don't know why that's there, but interface port channel 1, we specify all of our logical configurations. The port channel number is referencing the channel group number on the physical interface. So it's literally that easy to create an ether channel. Outside of the normal configurations that you would do on a port anyway, it's only a couple of commands. Now notice that one side of the ether channel is configured as active, the other side of the ether channel is configured as passive. All right? One side of the ether channel is configured as active, the other side of the ether channel is configured as passive.
Is there a reason for that other than?
No, I mean, you can make them both active, you just can't make them both passive.
Is there a reason to even have passive if you want it to connect?
No, not really. I would probably just make both sides active. I just wanted to demonstrate that you could do active and passive here. How do I verify my ether channel? It's very simple. All right, this is the same configuration, but this is for patch P. Notice that the patch P configuration is absolutely identical to the LAC-P configuration with the exception of one thing, the mode. All right. Now, if this is Cisco to Cisco, patch P will work just fine. It's not that one protocol is more efficient than the other. They both perform the same function to create an ether channel. All right. Of course, you can't use patch P if you're trying to create an ether channel to a non-Cisco device. How do I verify my ether channel? Yes.
So if you get a Juniper, it will have LAC-P
Yes.
available.
Yes. It's an open standard. IEEE. Now the syntax will be different, of course.
Right. Yeah.
But the actual communication protocol is the same because it's an IEEE standard. Right? Show ether channel summary. As you can see here, I have channel group number 1 with port channel interface 1. SU is the status of the ether channel. S means it's a layer 2 ether channel. U means that it is in use. I can see that the protocol that I'm running is LAC-P, and the ports in the ether channel are 1-1 and 1-2. P means participating in the ether channel or bundled in the ether channel. Now it is possible that you would see other status here. If you see an I, for example, an I will usually indicate that there's a configuration on the physical port that is preventing that port from joining the ether channel. In other words, the physical port configuration is not consistent with all of the other ports in the ether channel. Maybe it's a different duplex. Maybe it's a different speed. Maybe it has a description on the interface that the other interfaces don't have or something like that. So if you see like I next to your ports, just make sure that you go check and ensure that your configuration is consistent across all of the interfaces.
So when you do a show IP interface brief or a show interface description, PO1
Will show up as an interface.
is what it, okay.
Well, it would be port channel.
Right. Well,
Port channel
IP
one.
interface brief, okay. We were using that now. I never really knew what that was for.
Yeah, it's to bundle interfaces together. Yeah. Now, there are different load balancing algorithms that exist for the ether channel. For the most part, and this is applied to my configurations in the real world, the default load balancing configuration is just fine for the ether channel. You can do load balancing based on IP address, MAC address, a bunch of different configurations. The default is to just do an XOR of the destination IP address. XOR is Boolean math. It's a way for us to calculate which packets go over which port in the ether channel. All right? But you do have the capability of setting different ether channel load balancing methods. For example, you can do a hash code based just on destination IP. Destination MAC, you can do it based on source and destination IP pairs. Source and destination MAC pairs, right? What are we talking about here? We're talking about running an algorithm that looks at those characteristics of the data and then decides what port over the ether channel it goes over based on those characteristics. Because this is a load balancing technology, isn't it? You have to send some packets over one link, some packets over another link, some packets over another link. So there has to be a way for the switch to calculate how that load balancing occurs.
So on a 24, as an example, 24 port switch, is there a maximum number of ports that you can use?
It depends on the switch model. Typically, it's limited to 8 interfaces in an ether channel. Okay, you're typically limited to 8 interfaces in an ether channel, but it does depend on the switch model. All right. How do you verify ether channel loading? You can do a show interface, port channel 1, ether channel. Now, to verify the effectiveness of the loading mechanism, we use this command. The links are actually displayed with a hex load value to get an idea of how each link traffic load relates to the other. So we see a load value of 55 and a load value of AA in this case. AA is 10101010 and 55 is 0101 and 0101. Now, there is a calculation called an RBH, a result bundle hash. And it's kind of beyond the scope of this class to talk about what that result bundle hash does. But there is a calculation that the switch does internally to determine what packets are sent over what link and what packets are sent over another link. In this case, for Ethernet 1.1, which is the top one in the table, bits 1, 3, 5, and 7 are set. Now, what do I mean by 1, 3, 5, and 7? Right? Bits 1, 3, 5, and 7. Remember, that's the 55. Bit 1, 2, 3, 5, 6, 7. Right? Bits 1, 3, 5, and 7. So an RBH value of 1, 3, 5, and 7 will be chosen. We'll choose Ethernet 1.1. And then for Ethernet 1.2, bits 0, 2, 4, and 6 are set. So that those bits will choose, well, that should say Ethernet 1.2, not gig 3.2. Let me switch that real quick. Now, that doesn't tell us a whole lot because of the algorithm that's occurring in the background, right? But these are called pairs, right? These are, this allows us to identify how traffic is going to be sent over each of the interfaces, all right? Now, I would not normally even have this slide in this deck, but I put it in here because there's a test question directly related to this on the exam. So I wanted to make sure that you guys got some exposure to that. In all of the years that I've been doing configurations, almost 30 years, I've never changed the ether channel load balancing method. Just leave it to the default.
Which one of those was default? Or is it in the list?
IP, destination IP is the default.